So let's think now. So we're in homework number 1 right now. I'm getting you ready. I'm going to actually do the homework in a second. This is like the warm-up, then we'll dive in. So like how would we do base 4? So we have up here base 10. So what do? You start with the 1s. Every system start with the 1s, and you go times whatever your base number is. In the base 10 system, we go times 10 to the first, 10 to the second, 10 to the third, times another 10 every time. So in the base 4 system, we'll start with the 1s. We always start with the 1s. And this will be the 4 to the 1s place, the 4 to the 2s, and the 4 to the 3s. So it's the same kind of thing, just for a different number than 10. So in other words, this is the 1s, the 4s, the 16s, right? 4 times 4. You can use calculators on everything in here, by the way, tests and homework and everything. 4 to the 3rd, 64. So that's the 64s place. So in the base 4 system, this would be the 1s place, 4s place, 16s place, 64, and on you go. So therefore, what would this number be? Like, let's just go 2032. So what would, in base 4, and this is how we indicate that it's base 4 and not, like normal base 10, is you subscript, right, at low down, like submarine is low down, you write 4 or whatever base you're in. So when you read, this is how you'll see it in the homework and the test and everything. When you see 2032, base 4, so a little 4 there, you go, okay, that's not a base 10 number, that's a base 4 number. This is the 1s place, and then 4 to the first, 4 to the second, 4 to the third. And then, okay, so it's 2 64s, 0 16s, 3 4s, and 2 1s. So we just, how am I going to figure out 2 64s? What do I do? Just multiply, huh? Yeah, just 2 times 64 plus 0 16s plus, right, 0 16s. 3 is the face value. There's 3 in the 4's place, and there's 2 in the 1's place. And then just use your calculator. What is that? 128, 12, is it 142? Let's make a calculator. That was, okay, thank you. So that's the number 142, like we're used to. So 2032 base 4 is the same as 142 base 10, normal. Did that make sense? Yeah.
The top numbers, it doesn't matter what number it is, right? Like
Top.
2032, it doesn't matter. It's just random numbers out there.
Oh, I just happened to make it up. Yeah. And they'll give us particular ones. Veronica, right? Yeah, you're right on Veronica. That's right. They'll just, they'll give us ones. Yeah, let's look at the actual homework. One more of these, and then we'll change. How about if I give you, let's say, base 3? Let's do base 3. And I say 212 base 3. 212 base 3. So that's base 3. I'll let you figure out what the place values are, and then multiply, add them up. See if you can figure out what that number is. This is pretty much my style. I show one, give you one, show one, give you one, and we'll do the homework. I'm about to dive into the homework. And I'll try to do one of each type and let you try some, and that's the plan. All right, so this is the 1's place. The 3 to the 1, 3 to the 2, so it's 1's, 3's, 9's place, huh? Remember, you just multiply by 3. You always start with 1's. All the systems start with 1's. Every system starts with 1's. Then you just go times 3, times 3. You don't even have to write these. You just go times 3, times 3. It's good enough. So that's how the place values always go. So that's 2 in the 9's place. So 2 times 9. Plus 1 in the 3's place. Plus 2 in the 1's place. So whatever that is, that's kind of good. Let me know if you can't read something. I kind of scribbly sometimes. So at 18, 21, 22, 20, 23? Yeah. Did y'all get that? Is that going okay? Is that making sense? How we change that? So see how that's making us think really intentionally about place value? Which is how it'll seem to kids at first. Like, why is it a big deal that this 2's over here and this one's here? It's just 2. Well, there's a place value to things, huh? And you guys just know it intuitively because you've been doing base 10 all your life. But kids will have to think this kind of way at first about the place values. In fact, there's base 10 bucks. I'll show maybe a picture of those later that are a very helpful tool for showing kids about this. Anyway, though, let's move on. Let's think now. So questions, feel free to jump in. You have questions, just jump in at any time. So let's think about counting now in the base 3 system. Let's do base 3 first off. Let's count in base 3. Okay, so I'm going to start with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How about, yeah. All right, so I'm going to count. Now that's base 10. Over here is base 10. This is just normal on this side, 1 through 10, like you're used to. But on the right sides, this will be, this side will be base 3. That left side is base 10, normal. All right, so how are we going to count in base 3? How do you say 1 first off? Well, 1's just 1. Nothing big there. Remember, let's go over here. This might help us. So in the base 3 system, this is the 1s, the 3s, the 9s. Right? So far, so good. So we're saying if you just put 1 in the 1's place, yeah, that's 1. Okay, how do you do 2? Well, 2. It's a big deal. 2 in the 1's place. How do you do 3? Well, 3. Well, let's hold on. There's another way to make 3, isn't there, in the base 3 system? Yeah, how would you make the number 3 in the base 3 system? 1, 3, and no 1s. That's also 3, isn't it? Does everybody see that? Let me pause there for a minute. 1-0, you can call it 10 if you want, but I'll say 1-0 so we don't get confused. 1-0, 1, 3 is 3, and no 1s. That's 3, isn't it? That's 3. So you would count 1, 2, and you go 1-0. That's pretty weird. 1, 2, 10. Isn't that weird? Everybody see that? 1-0 is actually 3. Let me give you the key now. In base 3, you're never going to write a 3 or bigger. You'll never see a 3, 4, 5, 6, 7, 8, or 9. In base 7, you're never going to see a 7 or bigger. In base 5, you're never going to see a 5 or bigger, etc. Whatever base you're in, you never see that number or bigger. Because whenever you're about to make that number, it means you shift to the next column. That's what that means. Let's keep going. It'll make more sense for you. Let's go to, so what would be the next one? So you just keep adding 1. Here's let me say it real clear for you. You just keep adding 1, and anytime you're about to write 3, instead carry. So let's go. So 1-0, add 1, 1, 1. Is that 4? Is that really 4? Yeah, look over here. 1, 3, and 1, 1. That's 4, isn't it? Good so far? Just keep adding 1. 1, 2. Is that really 5? Yeah, 1, 2. It's 1, 3, and 2 1s. That's 5, isn't it? Okay, keep adding 1. 1, 3. Oh, but I can't do that. So you just keep adding 1 until you write 3. Then you go, nope. Can't write 3. We're never going to see a 3 in base 3. Well, what do we do then? That means we carry to the next column. What do I mean carry? It means you come over here and you make that a 2, and this is back to 0. Let me show that again slowly. So in other words, I was at 1, 2, and I started to write 1, 3. Instead, we carry. Now, this is also making you think really intentionally about carrying when you add, which is really confusing for little kids when they first learn it. Like, why are we moving these numbers around? Well, it's exactly this. Because you've reached the base limit level. So when you add 1, I'm trying to add 1 to 1, 2, right? Thinking it's 1, 3. But in reality, I can't write 3. Never going to see a 3 in base 3. So what do you write instead? 0, carry the 1. Does everybody see that? When you're about to write 3, instead you write 0. Okay, why? Because remember what 3 is? Remember what 3 is? It's 1-0. It's carry the 1. Bring down the 0. This 1-0 is the 3. Really, you could say, well, I don't want to, I'm probably confusing you by giving you too much at once. So just, when you're about to write 3, instead of writing 3, cross it off, put 0, carry the 1. That's the rule. Next column, 1 and 1, 2. So 2-0. So that's 2-0. Is that really 6? Is 2-0 really 6? Yeah, it's 2 3s and no 1s. That's 6, huh? This making sense? Getting the hang of this? Let's keep going. Just keep adding 1, 2, 1, 2, 2, 2, 3. Oh, nope. There it is again. Right? So anytime you're about to write that 3, okay, so let's go back. So I was at 2, 2, and I tried to add 1, huh? And I started to write 3. Nope, cross it off, put a 0, carry the 1, 2 and 1, 3-0. Nope, no 3s there either. No 3s anywhere. Isn't this getting weird? This is exactly how kids will feel. So this is kind of meant to make you feel off balance so you'll really understand what's really, because it's so natural for you now. You know, if I put regular numbers up there, you guys could do them in your sleep, right? Because you just sense and smell the base 10 system. You've been doing it for so long. But this is actually the math behind it that is hard for kids at first. So really, what am I supposed to do instead of this 3? Put a 0, carry the 1. 100, 100. 100. That's how you make 9. Is that really 9? Yeah. 19 and nothing more. That is 9, isn't it? Do you see how that's working? And then they just add 1, 101, done. So again, so we're going to shift to other bases. Do you get the pattern? You just keep adding 1, but when you're about to write 3, you write a 0 and you carry it. That's really the rule. Let me write that out. So, hey, well, how about we do it in base 4? Count in base 4. So here's the rule. When about to, well, I should have said keep adding 1. Let me start there. Start at 1. Start at 1. Keep adding 1. So now I'm giving you the rule here. Start at 1, keep adding 1. But when you're about to write 4, since whatever the base you're in this case 4, when you're about to write 4, instead write 0. Instead write 0 and carry to the next column. To the next column. Which is really exact. I'll show you that that's actually what we're doing in our system too. All right. So let's try it. Well, let me let you try it. Can you try it over there on the side? How about you just do the first 10 numbers in base 4? We'll just try that. That's exactly what we're doing the homework basically right now. This is like number 1 in the homework. So I'll go 1, 2. So here maybe I'll do base 10. So base 10 normal 1, 2, 3, 4. That should do 5, huh? I'll do 5 and 5. So base 10. 1, 2, 3, 4, 5. And over here we'll do 6, 7, 8, 9, and 10. All right, so there's the base 10 numbers. Now change them into, over here will be base 4. So 1, start at 1. Just keep adding 1. So 2, 3. Yeah, I'm about to add 1. So I'm about to take the 3 and add 1. About to write 4. But this is base 4. So we don't write a 4, we write a 0, carry the 1. 1L. It's making sense? Am I racing ahead of you? That's good? So keep going. Keep adding 1. Just, as long as you just add 1 and you don't write 4, there's nothing weird. But it's just when you're about to write 4. So keep going. Maybe you've already finished. Give you another second. Finish that up. This will all be on YouTube right after class in case I'm going too fast. I don't know if you found or looked. Probably not yet. But there are all my lectures out on YouTube. I'll write them up there again somewhere. Yeah. You just go out to YouTube. It'll all be there. So if I go too fast, you just want to see it again when you're trying to remember. What that guy do in the homework? Go to youtube.com, search my name. My name's on the syllabus. And I have all my classes out there, so you gotta find this class m10a, not 10a. So they're all out there. It'll be recorded, exactly what we're doing now. All right, so here we go. So just keep adding 1, 1, 1, 1, 2, 1, 3, 1, 4. Nope. So instead, when I'm about to write 1, 4, instead make that a 0, carry 2, 0, huh? 2, 0, and then just 2, 1, 2, 2, done. Good enough? Is that making sense? Would you believe it if I say that's exactly what we do in our system, but you just don't even think about it? Watch. Let's count in our system. What's our system? Base 10. Let's just get all the 8, 9. Now, can I make 10 with 1 digit? No, what do I do next? In base 10, you don't write 10. I know you think, well, yeah, we do. Well, not 10 in one spot. Do you get the idea? Just like over here, of course I do make 4. That is 4. in the base 4 system, right? Right? In the base 4 system, that is a 4. Let me make sure you're clear on that, because this is the 1's place, the 4's place. So 1-0 is 4, isn't it? This is 4. But you don't make it with one digit. That's what I'm saying. You don't make 4 with one digit. You need a second digit. In the base 4 system, you make 4 with 1-0. Well, same way. In the base 10 system, you make 10 with 1-0. You can't make it with one digit. That's exactly what will be confusing to kids. They'll think 8, 9, and they'll want to make 10 with one digit. But they've reached the base number, just like when we beat base 4. Question? Comment?
Yeah, I don't get your explanation.
Anthony?
Yeah. What you're doing with the numbers in top right, I don't get it.
Up here?
Yeah.
Oh, like this right here? Oh yeah, I was saying this is the base 4 system. So in the base 4 system, what is the number 1-0? In the base, yeah, I probably did that real quick. So everybody get that? So you start with the 1's place. Somebody said, hey, what's 1-0 base 4? Start with the 1's place. Next come the 4's, the 16's, the whatever 4 times 16 is. Remember how to do numbers in a certain base. Start with the 1's, 2 times 4. Yeah, so I was saying it's 1, 4, and no 1's. It is really 4. Yeah, exactly. Good. All right. A little bit more. Some of the problems, it randomizes them when you do them, so it'll probably change it for you, the base, whatever. Randomizes it for everybody. Some of them don't. Some of them are exactly the same because they're questions I made, and they don't randomize. They're fixed. So you'll see a mix. Anyway, so part A says, what are the first 15 counting numbers in base 5? So basically, wants you to count in base 5, and this is exactly what you'll enter into My Math Lab. You'll enter all these numbers with commas. So, here we go, counting in base, what are we counting? Base 5. So this is base 5, counting. So 1, 2, 3, 4. Here we're about to write 5, but instead of writing 5, you write a 0 and you carry, See, it's the same exact rule, 1-0. And then you just go back to adding 1. Just go back to normal. 1, 1, 1, 2, 1, 3, 1, 4. Here I'm about to write 1, 5, but instead you make that a 0 and you carry. That's why it's 2-0, 2, 1, 2, 2, 2, 3, 2, 4. I'm about to write 2, 5. Instead, write a 0 and carry 3 out. You get it, right? And then base 8 is down there. Same kind of thing. So we're learning to count in other number systems on that. All right, so let's move on. So the rule is, notice in base 5, you never see a 5. Right? See everything except, 5 or bigger. You don't see 5 or bigger. Just 1, 2, 3, 4. In base 8... Here's base 8 on part B. Base 8, you never see an 8. You see everything up to that, up to 1 through 7, but never see an 8. So now the question, so they're saying, so let's make sure there's the answer for you. In the base 25 system, there's going to be 25 different digits. They're counting 0. I don't know if that's confusing for you. So in other words, let's think about base 4 that we just did. In base 4, how many different things can you write? 0, 1, 2, and 3, You can't write a 4 in base 4. I mean, not with one digit. You can make it, but it's 1-0. Getting the hang of that? We're talking about how big of a number can you make with one digit. What's the biggest number I can make with one digit in our number system in base 10? 9. So notice it's always one lower. See how that's always the case? In our system, the base 10 system, the biggest thing you can make with one digit, the biggest number you can make, the biggest amount is 9. So in the base 4 system, the biggest thing you can write with one digit is a 3, etc. See how that's consistent? It's the same logic, but it sure doesn't feel the same, does it? Because you're so used to the base 10. So when they ask how many different, there's actually 4 different things you can write. They're counting 0. So in the base 4, there's 4 things. Right? In the base 6, there's 0, 1, 2, 3, 4, 5. So there's 6 things, etc. Whatever the base number, then that's how many different symbols you need, counting 0. So in base 25, you need 25. In base 4, you need 4. In base 6, you need 6. In base 25, you need 25. They're making sure you got that idea. Is that good? So in a couple weeks, these will turn into test questions, just like homework. I aim to not surprise you. So I'm showing you what's in the homework, and then I'll give you a practice exam, which will be these, and then I'll give you the real exam, which will be these, So please speak up. If it's not making sense, I'm glad to help. So let's go on. So then in number 3, but stop me at any time, 5053, base 6, they want us to change. They want us to first off write the expanded notation, like the place values. So let me just get a fresh screen where we have room to work here. 5053, base 6. Okay, so number 3, is 5053, and that's base 6. And so what our job is to take these different numbers and put the place values underneath them. Right, where do we start? Where's the first one? Always 1. Every system, huh? What comes next? 6, and then times 6. 36, and then times 6 at 216, I think. Use calculator. Those are the place values. Well, and they would call this 6 to the second, and 6 to the third, and this is 6 to the first. Yeah. So, and that's all they're doing. Look back at the question. See how they said it's 5, 6 to the thirds, no, 6 to the seconds, 5, 6 to the first, and then just 3. That's the right answer there. It's multiple choice. Good? They're not even having to figure out what the number is. They're just making sure we understand the place values in expanded notation. They're just saying 5053, this is the 1's place, this is the 6's place, this is the 6 squared, and this is the 6 cubed. There it is, 6 cubed, 6 squared, 6 to the 1, and then just 3. Good? And then number 4, find the numeral preceding and before and after. So a little more practice. Just another way. This is 430 base 5. Okay, so they're going to ask on question number 4 in your homework. It's exactly what your homework will look like, just different numbers. They will ask for the number before and the number after. So we have 430 base 5. They want us to subtract 1 and add 1, back up 1 and go forward 1. All right. So what's the number? Here, let's do after. Let's start with after. What's the number right? Remember how we count? It's just counting. It's just counting again. You just add 1 every time you go up or subtract 1 every time you go down. Except when you're about to write 5, you don't. You write 0 and you carry. Otherwise, just add 1 or subtract 1. So what would be the next one? We'll just add 1. 431. No big deal there. But what's the one right before? That's a little more tricky. What's the number right before 430? Good job. Do you see? It must have been, because they wrote an O, there must have been a 2 here. And they carried, huh? Whenever you see an O, that means they carried. They added 1 and they carried. Now, is it 9? It's not 9. You're never going to see a 9 or 8 or 7 or 6 or 5 in base 5. The highest thing you can see is 4. Right? In base 5, the highest thing. So it must have been. Is that right? See if we added 1 here. That would be 5, which means 0, carry. Yeah, 430. Everybody see that? It must have been 424. Is that good? See how that's kind of weird? Like, where'd that 4 come from? That's how kids will feel about where the 9 comes from all of a sudden in our system. It's the same thinking. All right, so what else do they give? 9. So 1 with 5 zeros, base 9. Here, let me move it to the middle. It's the same thing. They want before and after. So 1 with 5 zeros, 4, 5, base 9. So they want the number before and the number after. Okay, let's start with the number after. I'll do the number after, you do the one before. So what's the one after? I'm just joking. What's the one after? We just add 1, huh? 3, 4, boom. So just add 1, no big deal. But what's the number right before? Did you see it when I had the answers up there? Yeah, it's a bunch of 8s. Did you notice that? Does that seem right? Yeah, because in base 9, what's the highest thing you're going to see? 8. You're not going to see a 9. Right? So it's a bunch of 8s. How many 8s? Well, all of these spots, and then the carry brought the extra 1. What's that? 5 spots. So 5 8s. Let's double check that. So meaning, if you, get this out of the way here, if you added 1 to that, do you see what would happen? 8 and 1 is 9, but you can't make a 9 in base 9. Getting the hang of that. Can't make a 3 in base 3. Can't make a 5 in base 5. Can't make a 9 in base 9. So instead you write a 0 and you carry, and then that's 9. But you can't make a 9. Same thing. 0. See, it keeps happening. 9, 0, carry, 9, 0, carry, 9, 0, carry. Yep. That must have been the number before. Is that good? Felt like you could do that on a homework test? Questions? Feel free to speak. And now they want you just to change to base 10. Just make it normal, in other words. So give that a try. Feel free to use your calculator. So take 242. There's, of course, no cell phones on this. You can use cell phones now. It's totally fine. But make sure you have a regular calculator you can use regular tasks, because, of course, you can't use cell phones. That you can text answers back and forth with all your friends. You wouldn't want to do that. Not that you would do that necessarily, but I have to keep the security there. So 242 base 5. So let's go through the place values. So just write in the place values. What's the first one? Ones. Next. 5, because we're doing base 5 here. Next. 25. Good, and then figure out what that number is. We're just doing the place values. If you're gonna, if you have any old calculator around the house, that's fine and good. Just use whatever you got. If you happen to not have one and you're going to buy one, I can make a suggestion that is nice for the students always like. The Casio Natural Display, it's cheap as any of the others. $10, probably bookstore, Walmart, Target. Well, it might be 15. Somebody told me Target had it for $9. I'm not sure I believe that. But I think it's probably 15. Anyway, it's a little easier to use than most, because it looks really, like the name says, natural. It is very easy to use. Anyway, I wouldn't run out and buy that if you've already got one. You know, it's not magic or anything. But if you're going to buy one, that is a superior one. But yeah, any calculator, make sure you have that. All right, so 2 25s, 50, 4 5s, 20, 2 1s, 2, 72. Making sense? Just converted that to a normal number, making sure we understand those place values. That's not too bad so far. That one. So they're giving us 11001. Let me make it a little, spread it out a little bit. 11001 base 2. Base 2. What does that look like? What uses base 2? It's binary, 2 states. Right? There's only 2 numbers. In base 2, you're never going to see a 2. So what are you going to see? Zeros and ones? And what uses zeros and ones? Computers, all computers. This is the language of computers, because a wire is either hot or cold. It's either got current or it doesn't. That's the 1, 0. That's how computers work. Everything's on the computer level, it's in binary. That's how they communicate everything. It's all binary, because all those wires, and they make them super tiny now on those chips and everything, but there's zillions of little wires, and they all are either on or off. Either there's current in a wire or there's not. That's how they communicate all their codes. So this is going to represent a number. With this code, wire on, off, on. Those are 5 wires. That's how hardware is programmed. That's how it actually works. So that would be 5 wires in a computer. These 3 are on. Those 2 have no current in them. And that's communicating a certain number. Can you figure out that number? And then I'll leave it there for a second. So then find out what number is that in like a normal number, base 10. Change to base 10 again. So put in the place values and calculate that out. So you start with the ones place, always. And then go times 2, times 2, times 2, times 2. Good. So that's 1 in the 16's place, 1 in the 8's place. So that's 16 plus 8, and 1 in the 1's place. Whoop, not 18. Just 8. 24, 25. So that's the number 25. And if they wanted to spell out a word, they would connect that with the alphabet. So there's 26 letters in the alphabet? So the 25th letter is Y. That'd be a Y if you wanted to do it that way. That's how they would begin to spell a word that started with Y. That's how the computer would see a Y, 11001. That's what it can do. That's how it all works. And so that's how just wires on and off can actually become a whole language using the binary system. There's, of course, much more to it than that, but that is the fundamental level. Is that making sense? Questions I can answer? Now that's weird. Why is there a letter in there? Yeah. So remember how the base value system works. So whatever your base value, you're never going to see that number, huh? So in other words, in base 5, you're never going to see a 5, at least not with 1 digit. In base 7, you're never going to see a 7, at least with one digit. You need to carry to do the 7, right? So in base 12, you're never going to see a 12, okay? But you are going to see an 11 made with one digit. And a 10 made with one digit. And, of course, 9 all the way down to 1 and 0, of course. Do you get what I'm saying? So like in base 7, you won't see a 7, but you'll see everything up to that, up to 6, made with one digit, not two digits. Right? So what's weird about this question? Let me help. Is we're going bigger than our base system now. Everything we've done so far has been less than 10, hasn't it? Right? We have a base 10 system. We've been doing problems with smaller than 10 numbers. Now we're finally going beyond our system to base 12. That's a little weird. So think about what it means. In our base 10 system, you can have 1, 2, 3, all the way to 9 with just one digit, huh? In the base 10 system, you go all the way to 9 with one digit. To make 10, you need two digits. That you know. So that always means in any base system, you can go up to one lower than the number with one digit. So in the base 12 system, you can go all the way up to 11 with just one digit, huh? One lower than the number. So how do you do that? How do you make 10 or 11 with just one digit? Well, they just say use T for 10 and E for 11. It's not all that creative. But the point is they're just using one digit, not two. They don't write 12. They don't write 11. They have to make it with one digit in the base 12 system. Is that making sense? So like in our system, base 10, we go all the way up to 9 with just one digit. That's what you'll teach kids, right? All the way up to 9 with just one digit. And then when you want to do 10, you need two all of a sudden. So therefore, you always go up to one less than your base number with only one digit. So at base 12, we have to go all the way to 11 with just one digit. All right. So with that in mind, can you figure out what that number is then? So just that E, if you ever see an E, it's 11. If you ever see a T, it's 10. And then just figure out that number. So this is the ones place. Let's always put the place values underneath, huh? Ones place, and then you just go times 12, because that's base. Times 12, this would be 144. Good. So this is 7 144s, whatever that is, plus 6 12s, plus 11 ones. Does that make sense? So somebody help me out here. Was that 700? I don't know. 980 and 28,008? 1,008? Thank you. And 72 and 1. Is it like 1,081? I think I did that right. 1081. That 76E is 1081. Did you track with that? So it's the same kind of thing. Higher base, 1 times 12 times 12, and then just multiply. I don't know. E's 11, T's 10. We good? Let me know if you want to do more. Good? Yeah.
You're not going to do 11 by 9. It just becomes 1.
Oh, no, I did. 11 times 1. Oh, I messed up. Oh, I'm glad you said something. That's craziness. What am I doing up there? You are totally right, and I am just goofing up. 11 times 1 is 11. So this should be 91? Is that data right? 181? Yeah, thank you. I'm just totally wrong. Yeah, thanks. I just went too quick. That good? I was testing you. Well done. Anthony.
What are the numbers under 10?
Yeah, under
The word 10.
Oh, I'm just showing if you go from 0 all the way to 9, 10, 11, how you would represent them. Yeah. And mainly all you need to know from that is E's 11, T's 10 in the system. Yeah.
So, what if we were to get like 18 to the 18?
You'd need more stuff, wouldn't you? You'd need like more letters to represent. Now, I'm not going to go. The highest I'm going to go is base 12. But if you're interested in the real world, computer world, that kind of world, they use base 16 a lot of times for whatever, I don't know why. But I know base 16 is used a lot. And in that case, what they do is they just start using the alphabet. A, B, C, D, E, A is 10, B, they shift. You know, we just use T and E because that's all we need. But for base 16, they go A is 10, B is 11, C is, they do it that way. That's how it's actually done. Let's see if we can squeeze one more in. We want to use stuff. So it's number 9, 178 to base 6. So number 9, 178, 2 base 6. So now the trick on this one is we're going the other way. See, the other ones I gave you, we started with the weird base system, the foreign base system, and we went to normal, went to 10. This one is backwards. So we're starting with 178. How do you know about that? As you look at that 178, well, it doesn't say anything down here like 6 or something. It's just a normal 178, so it's just a normal 178. And they're saying change it into base 6. So how do you go into a foreign system? We've come out of. How do we go in? In other words, it's I'm not going to come under here and write 1, 6, 36. That's not what I'm going to do, because that's not what those are. Those are those are normal numbers, right? That's not 1, 6, 36. This is the tens place and the hundreds place, which you know. I'm not even going to write that because you know it already. So that's a normal number. That's not a base 6 number. I want to change it into a base 6 number. So how are we going to do that? I'm probably going to run out of time, but I'll just start it and then we'll stop. Basically, the first thing to do, this is a little harder going this direction. You better write out the place value. We better do that. That'll help us. Let's write out the base 6. So you start with the 1s, as you know. Times 6, times 6, times 6. Just keep going until you're beyond your number. I'll write all this out next time. I just want to do you a quick overview, and then we'll do a bunch of these on Wednesday. But notice I just started. I'm writing out the base 6 place values. You start at 1. You go times 6, times 6, times 6. How far do you go? You go until you're beyond your number. In other words, we don't need any 216s to make 178, do we? So then you start here. And you say, how many 36s do I need to make the number 178? How many 36s are in there? How can you answer that question? How many 36s in the number 178? You divide. That's a divide question. You take your calculator and you go 178 divided by 36. And it'll tell you, what will it tell you? 5? 4.9. So just use the whole number. Don't worry about this. Throw away the decimal. 430, because that's the whole amount of 36s you can do. 4 36s, how much is that? 144. So we have 144, 34 left to go, which is 5 times 6 is 30, and 4. I know I just brushed that real quick. We'll stop there. We'll do a bunch more of that.